Hello everyone. This is Ethan Zhou, and this is my final project presentation for EE538. And in this project, I implement such functions. This is the brief summary of those functions. And the first function is autocomplete word. In these functions, we implement an algorithm that when we input some part of the location word, and all possible word location will be output. In this example, we input pickle, and all the location name that start with pickle will be output. And in the second example, we input Venice, and all location name that start with Venice will be output. And to check if the result is correct or not, we also write a Python program with pandas package to check if the output are correct or not. But by comparing those two results, we confirm that the output is right. And then the second function is find the locations. In these functions, we input the location name and output the coordinate of the location. First example, we input rows and it will return the latitude and the longitude of the rows. But if we input the wrong locations, the program will remind the users. In the second example, we input ROSE rows, and the program will remind the user that do you means ROSS instead of rows. So this will help me. This will help me to always get the right coordinate of the locations. And then to implement the reminder mechanisms, we should find the added distance between all the location names and output the location name with minimum added distance. And as shown in the chart, we're using DP to find the closest added distance. So here are some examples to show that the reminder mechanisms. We input Trader Joe without S, and the mechanism will help us to find the right location name. And we input KFE, and the reminder mechanism will find the right location name, such as KFC. And then the next function is that find all the location categories. In this function, we can output all the location categories. We iterate all the location and insert the location attribute into an order set to avoid the duplication of the attribute. We also write a Python program to check the output. And both the result shows that the output and the algorithm are right. And then the next function is get all location of a category. In this function, we're using an order map to implement these functions. We input a category and return all the locations that belongs to this category. In this example, we input bank, and it will output all the location ID that belongs to bank. And we also write a Python program to examine the result, and it shows that the result is right. And then the next function is get location using a regular expressions. In this function, we accept the correct regular expression and return the relative location names. Here we input a correct regular expressions, and we will output all the location names. However, if we input a wrong regular expressions, the program will output a regular error. And then if we input dummy, the program also will remind the user that there is no existing any location that fit these expressions. And then the next function is find shortest path. In these sections, we implement the function by two algorithms. One is Digicostura and the Bellman-Ford. We're using list two algorithm to find the shortest path between two locations. We will input a start location, and here we input target, and then we will input a destination, and here we input roast. And after that, the function will output all the paths and the distance of the path. And in here, we can also see that the runtime of those two algorithms are different, and the Digital is faster. And what's more, to see the path more clear, we also using OpenCV to plot the path on the map, and it shows that the paths are correct. And the next function is circle detections. In this section, we input 4 parameters: the left, right, upper, lower bound, and using this bound to get a circle region and find if there exists a circle path in the region. Here we also plot the region on the map to see clearly if there exists a circle path or not. In the first example, we can see that there really exists a circle path on the yellow region. And in the second example, we can see that there does not exist any circle path in the regions. And the then is the topological source. In these sections, we improve the CSV file that store dependency and all the locations name. We're using DFS to iterate a dependency to find the correct topological sort of all locations. Here we input such dependency. Here is the dependency. In the dependency file, they have source node and a destination node. After iterate all of it, we can get the right result. And here is the result of this example. And we also plot the result on the map to have a more clear perspective. And it shows that the result is right. And then the next function is traveling salesman's preference. In these sections, we using 3 algorithms to implement this function. They are brute force with backtracing, and 2-opt. In this example, we select 10 places in the and see that the 3 algorithms have different runtime, and the 2-opt is the most fast, and brute force with backtracing is the second one, and the brute force use the most time to get the result. And to compare these 3 algorithms, we also have animation to show that the difference between these 2 algorithms. Here is the animations for brute force and brute force with backtracing. By compare, we can see that the brute force with backtracing has less change than brute force. This is because brute force with backtracing will prompt some branches in the FS algorithms. And then this is the animation for 2-opt. Okay, in 2-opt animation, it shows directly that just with a little few change, we can get the result. And through the former output, we can also know that 2-opt algorithm is the most faster algorithm in solving TSP property. And then the next function is find nearby. In list sections, we improve the attribute, the source locations, radius, and the number, and then we will output the n location with same attribute. Let the distance to source location is less than the radius. In here, we just output 3 locations. This is because only 3 locations meet the conditions. So we just output 3 locations. Then to have more clear perspective, we plot the result on the map. In here, we can see that the green point represent the source locations, and the other red point with numbers are the result we output. And the next section is that shortest path to visit all nodes. In this section, we import a CSV file which stores all nodes that we should visit and return the shortest path to visit all the nodes. To achieve this goal, we use DFS algorithm to solve this problem. And here in the PowerPoint, we can see that our input dependency is here. We should visit 3 locations. They are Ralph's, Rose, and Trader Joe's. And then by using DFS algorithms, we can output the shortest path to visit all the nodes. And here is the result path. And to see the result more clear, we also plot the path on the map, and it shows that it is correct. And the last function is that it check exist of path with constraint. In these sections, we input some pair of start location, destination, and the volume of gas. Then program will return if we can using the volume of gas to go from start location to destinations. And in this example, I input target rows and with 0.5 volume of gas, and also input target to chase, and the volume of gas is 0.1, and now the last one is target to Rust with 0.01 volume of gas. And the result is yes, yes, no, and it shows that it's correct. And this is all the functions are implemented in this project. And I'm really happy that I enjoy this. I choose this project. I learned a lot of new data structures such as trail tree, node, and union find in this project, and practice then on some real problems. And what's more, I really had deeper understanding about more graph algorithms such as Digicustomera, Bellman-Ford, and 2opt. This project really improved my coding skill very much and inspired me to write more code. And I think this is all my presentation, and really thank you for watching.